Welcome, guys. We had a successful day one yesterday of our first Earth Space Science virtual lesson, and we are now going to move on to day two. I've tried to mess with a few technicalities, a few settings, so we're going to keep trying to improve day by day. But with that being said, I'm going to go ahead and go to share screen here so that we can see our Go Blue and get us going here. So share computer sound. Yep. Okay. Again, always new settings that I'm figuring out every day. All right. So if I look here, let's go to our Go Blue. And again, guys, like I said, my goal is always 15 minutes. I'm going to try and speed along as we go. And for our Go Blue questions, as you guys can see on page 9, we are moving on to a new page number now. As you guys see, don't forget there are going to be notebook quizzes every other Friday. So make sure you got those page numbers to a T. If you don't have your notebook with you, just make the first page, page 8 from yesterday. The next page, page 9, you will be on track as we go. Number 1, what shape do planets orbit the sun and who proposed this idea? Number 2, who pioneered using the telescope to prove the heliocentric model? And number 3, who built accurate equipment for viewing stars? Again, this is all about knowing your historical figures. Am I right, guys? Again, knowing those historical figures and what they did. On all actuality, if we had a test, it could be like a matching type of section. Likely to see questions on this on our quiz on Friday. Before we go on to that, though, as usual, again, our same announcements as yesterday. Third quarter grades have been completed. Do not forget, we have those article questions due this Friday. You need to submit those to me on Edsby in a written format. So take pictures of your written assignment with your name on it. You will get credit. And then lastly, our notebook check will be next Friday, as well as our unit quiz through Edsby that will also be on Friday. Now, again, just to show you guys, just to show this to you again, because I got a number of people asking me, where are the articles? How do I get them? Okay. Well, if we look here closely, I've recently actually done something new. I have pinned the assignment under pinned items. So if you go to the left here, you go to your pinned items. If you're on mobile with your phone, you will see the article attached below right here. It says solar impact articles. So those articles with those questions. If I scroll down, there's yesterday's video lesson. If I scroll down, you can see, again, great job. I got people answering my attendance polls for my attendance. Again, keep up with that, guys. You need to make sure you're doing that. But we can see here, again, I just got to click right next to assignment. Click where it says solar articles. That's where you're going to find both your submission button and the articles itself that you will be reading for submission on Friday. Okay, but let's get back to where we were, right? Hopefully this is turning out and looking okay. Where are we at? Oh, okay. Yep. All right, so back to our questions. Number 1, what shape do planets orbit the sun and who proposed this idea? Again, hopefully you'll pause and answer these already. And by the way, just so you guys know, before we get to those question answers, update your table of contents, pages 9 and 10. Today we are going to finish law versus theory shortly, as well as get into some solar system formation. All right, so number 1, the answer was ellipse or elliptical, kind of like an oval egg type shape going around the sun. Again, keep in mind, the sun is not at the center of this orbit. Again, orbits do not occur in a circle. They occur in a longer, stretched out oval shape that we call an ellipse and elliptical. And I'm also noticing that there is not one answer on this. And the person the person I'm going to need you guys to know is important figure that came up with this idea, that proposed this idea of planetary motion. Again, that is going to be Johannes Kepler. But for short, we will just go ahead and say Kepler. We'll just go ahead and say Kepler. Again, last names are more important than first names. So ellipse, elliptical, and then Kepler would be our person who identified that. Number two, who was the person who was innovated with the use of the telescope to make many incredible, innovated the telescope to make incredible discoveries such as other planets and moons? That was Galileo for number two. And number three, who was the person that made a lot of improvements to equipment used for absorbing a lot of our, observing a lot of our incredible discoveries in astronomy? That was a man named Tycho Brahe, spelt with Tycho Brahe, but pronounced Tycho Brahe. So keep that in mind as well. Okay, any questions on that, guys? Table of contents. We are all good here. New pages, 9 and 10, solar system formation. I had people ask me yesterday, do I need to worry about the old stuff? You know, I'm going to say this, probably not for the most part on the quiz. Quiz will just be strictly what we've gone over as starting with our e-learning. So I'll keep it to that. I'll make sure it's that. Maybe I'll add a few older things, but if not, it's already accessible through ESB, so can touch on some of those older things. Okay, let's go ahead and move on. All right, I'm gonna see here. Oh, okay. So yesterday, I'm so mad. Okay, well, it happens. I make mistakes in class too. So yesterday, you guys remember, I read off a question at the end of the presentation, and that question did not show in the presentation. So here you are, you see it now. What process helps power the sun? Is it A, nuclear fission, B, nuclear fusion, C, photosynthesis, or D, solar magnetism? And as we all are human, we make mistakes. I accidentally showed the answer just a second ago, hence why I said no. Which the answer, which hopefully you guys would know, was B, nuclear fusion. So make sure to take note of that. Again, B, nuclear fusion. Okay, moving on to where we left off from yesterday. Let's go ahead and take a look. We started off with some theory, started off with some some theory, and then today we've got to finish up with our law, right? With our law. So let's go to that. Again, staying within my time limits here, trying to be concise and to the point. We have our examples of theories, right? Evolution, the Big Bang Theory, geocentric, heliocentric, right? But we got to think about, again, from yesterday, what differentiates a law with a theory, right? How are they different? Is one better than the other, et cetera, et cetera? And we recall from yesterday, just to kind of recap again, and this is something, do not forget, guys, make sure you have your notebooks or your sheets of paper. You are going to be writing down what's in yellow. Again, feel free to pause as we go along. But in summary, guys, again, you have your facts, then you make observations, which lead to a hypothesis, a proposal, which results in testing and experimentation to develop a theory, whether it is true, a theory that is concrete, that is proven very true through a lot of evidence. Again, to get a theory, this is from yesterday. No need to write this down right now. Again, it's got to be well tested. It's got to be improved upon. It can be modified. Theories can be changed. Theories explain, right? Theories are going to be descriptive. They're not compared to laws. They're just different, right? Laws are going to be concrete and set. It's going to be more of a short, brief, concrete idea, whereas theories are descriptive. They explain. Look, evolution has to be explained, right? The Big Bang Theory has to be explained. These are not ideas that are explained with a concrete mathematical equation, right? So I just kind of scrambled. I kind of glanced over the stuff from yesterday. So let's get to the new stuff. Some new stuff. Okay. Law. Okay. Law, again, oranges to apples. One cannot become the other. One is not better than the other. Okay. Theories do not become laws. Okay. Instead of why or how, they describe what is happening. Theories, can they change? Yes. Laws cannot be changed. Laws are always going to be staying the same no matter what. It is simply a statement based on experimental observation of a phenomena in nature. So what does that statement include? Again, theory explains, explanation. It can expand. It can do a lot of things. A law is concrete. It's A to B, right? So some examples of laws include planetary motion. include motion as well. We've got gravity. We all know about that, right? And then the law of thermodynamics. Okay, so energy of mass, conservation of energy and mass. So all ideas to think about, ideas that can be put into a math equation. Okay, ideas that can be more mathematically based. It's a very short, concrete A to B situation. It's a math equation. It's a one-word text, right? Whereas the theory explains. It's a paragraph, right? I can't put evolution in a math equation. I can't put the Big Bang Theory into math equation, right? It has to be explained. Are we all good? We all clear? Awesome job, guys. Okay, so let's go ahead and do another quick question. Hopefully you guys can see me pretty solidly here. Okay. Well, actually, I want to show you a quick video that explains that, and that link will be posted to ESB for you guys to view, just to kind of further solidify those ideas that were mentioned. Again, differentiating a law versus a theory, right? I'm just going to play a little bit of this. That way YouTube doesn't get mad at me, right? Okay.
Okay, let's try another. Evolution is a fact. We know that it happens, no doubt. But how does it happen? Evolution by natural selection is a theory. We've come up with thousands and thousands of hypotheses about it, tested them, thrown out the bad ones. We developed a pretty darn good framework for predicting how living things change over time. So yeah, it's a theory. Stop saying it like a bad thing. Calling it a theory means it's passed the toughest tests that we can throw at it. And evolution has been tested maybe more than any other theory we know of.
So theories, guys, again, most of them are not really disproven. There are theories that are disproven, but the concrete ones in science, now that we have, there's a ton of tests and a ton of stuff backing it. It just can't be formulated in a mathematical equation, right? So again, that's what separates theory from law.
We should really call it the theory of law.
Let's go ahead, law.
In science, a law is a detailed description, usually using math, of how something happens, like the movement.
So keyword there, math. Keyword is math, right? That's the big idea. More mathematically based as opposed to ideas based, right? So gravity was the example he was going to use there. Okay, let's move on to some new stuff, which I guess I'll have to be a little brief about given the time I've got. We're going to talk a little bit about the formation of the solar system. How did our sun form? How did our planets form? Again, we're not talking about the universe, that's Big Bang. We're just simply talking about our solar system. So, thought questions to think about. Given what we know is in space, what exactly helps to stem the birth of a new star or solar system? We're not talking the universe, we're talking just a solar system. What is going to form that? What's going to create that in the first place? And then secondly, what caused the formation of far gas planets and closer rocky planets in our solar system? What contributed? So why do we have rocky planets that are close to the sun and gas planets that are farther from the sun? Think about that, pause the video, kind of contemplate that. But let's go ahead and go back to some practice questions just to see if you guys can recollect what we learned about the other day. Okay, so our first question here, as you guys can see, we've got what historical figure often used a telescope for many discoveries to support the heliocentric model? We just heard about that, didn't we? That person was oops, I said it, but you know it, Galileo, okay? Got to know the name with what they did. Know the name with what they did. All right, so let's go ahead and move on back to our solar system formations. As we can see here, again, just writing down what's in yellow. We've got our first video questions of the day, and I will not play this video because that is your guys' responsibility. You need to answer these on your own. Number one, what do stars form from? And number two, how do planets form? Very, very helpful, awesome video. We'll take a glimpse at, and I'll kind of show snippets of it later, but you guys need to watch it on your own with the description included. Okay, so let's get into it, guys, as I got to finish up here within the next few minutes. Stars and planets form from interstellar clouds. That kind of did answer our video, so use that to your liking. Which exists in between space and stars. So look at this picture here. Oftentimes when you guys look out into space, you see pictures of space. There's not just dark space and stars. There are colors, and there is like this kind of dusty looking pattern behind those stars. Guys, that is space dust. And when that space dust collects, it becomes what we know as a nebula, right? So what role does that dust play forming our solar system and stars? Well, guys, this dust is mostly just gas with hydrogen, helium, and it's got other elements and particles in that. And that space dust are going to be is going to be the ingredients for forming our solar system. Okay, again, make sure we're writing down what's in yellow. This is going to go to page 10, by the way, guys. Again, this stuff is going to go to page 10 beneath the question. And this is going to be what's called formation of the solar system. Again, formation of the solar system. So as I finish up here, guys, we've got basically what's going to happen is that dust is going to kind of get more dense, and it's going to come together. Gravity is going to be the strongest force in forming our solar system. It's going to come together and kind of organize stuff. So you see this cloud stuff here, okay? It's going to spread and then condense. And as it condenses, that's going to be kind of the precursor for basically our sun and our planets, right? So it's just a bunch of dust floating around in an area, and then the dust comes together, it collects together, it concentrates, and it's gonna eventually form a star and then planets. Kind of as you see with our video here. Well, let me show the video here in a second. I'm gonna show one more slide here, okay? And what happens after it collects? What it's gonna do is it's gonna slowly accelerate, and it's going to rotate, it's gonna spin and stir up the dust particles, those elements, with what we know as is a centripetal force that's spinning, kind of like a top spinning, kind of like cotton candy. I've said time and time again, cotton candy being stirred in the cotton candy machine. That is the same idea with forming our solar system, right? So again, think of a dense concentration of matter, a little circulating cotton candy stirring up. And I'm going to go ahead to finish for the day. That collapse is going to form it. To finish off for the day here, guys, we are going to look at this. This is in your video that you're going to see. Okay, you're going to see this, right? Okay, and this is in our video that I want you guys to watch and answer your stuff from. Okay, but you're going to see
these are protostars.
Nebula. We'll talk about the protostars eventually as well. But essentially, this stirring is shown right here.
The secret stars.
Okay, as you can see. Here is the dust spinning about, those gases spinning about, and as they ignite, we'll get into this later, they'll begin to form a star. There's the spinning again, that rotating disk. We call that what kind of force? Yes, centripetal force, right? That is forming our early solar system. And later on, again, it'll ignite, it'll settle, and you'll get a ton of these asteroids and particles coming together. So we'll get into more of that tomorrow, condensing. Again, that concludes my lesson for today, guys. I'm out of time. Again, don't forget we have our article analysis questions due on Friday. Submit those. We have our first unit quiz on Friday, and we will be having unit quiz on Friday, the unit quiz, article questions due Friday, and then lastly, notebook check is going to be on next Friday. So you guys take care. Have an awesome day. I will see you guys again with our next lesson on Wednesday. Mr. Campbell, signing out.